So in this video, we're going to be looking at tool calling in LangChain. Tool calling in LangChain. Now, tool calling is a very, very important feature in large language models today, especially with the rise of agents, because there won't be agents without tool calling, basically. There won't be agents without tool calling because agents are basically, pick my pen here. Agents are basically LLMs plus tools. Yeah, LLMs plus tools equals agents. That's basically what agents are. And we all know 2025 is the year of AI agents. So tool calling is a very fundamental feature that agents possess and use to make sure that they carry out their agentic workflows, basically in the aspect of calling external tools, making external, performing external actions, making external impact. So it can be from calling a database, performing a web search, executing code, and stuff like that. Tool calling enables all that. So how does tool calling work? First, let me change this to black because, yeah, I don't want it to be red. How does tool calling work? So what happens is this. You have your model. So you have your model. Let's see it as the brain of the application. So this is your AI model. This is your AI model. Then you give it a set of tools. Tools are basically anything that can perform a function. Anything that can perform a function. So it can be functions in your application. It can just be regular functions in your applications, even from classes and any other thing. Just a function. Yeah. Whether you call it subroutine, whether you call it method, whether you call it function, whatever paradigm you're working with, basically a function, something that can perform an operation. So you have tools. They are called tools. From just performing simple operations within code or complex operations within code to maybe calling an external service, sourcing data from an external source, or anything that performs an operation is a tool. So you take your model and you give it tools. You give it these tools. Let's say we give it a tool that does web search. We give it a tool that does web search. And this tool can be called with certain arguments, maybe with a query. Let's say it can be called with a query argument. Can be called with a query argument. We also give it a tool that can, let's say, source info. Let's say you can source information from a particular repository. So maybe we give it a database. So you can perform queries on a database. Or something that can, a tool called search documents. Let's say we have a tool called search docs. And we're going to give it, let's say, a file or a file path. So we have these different tools. We have the different tools and we give them to our model. We bind them, as you will see later, to our model. So when a user comes and queries our model and says something like, let's say what query can be interesting. The user comes and says, who is Katy Perry? Who is Katy Perry? So the user asks, who is Katy Perry? Now, which of these tools do you think the model is going to go for? Definitely the web search. So this query goes to the model, or this prompt goes to the model. And the model says, yeah, this looks like something I need to go online and search for so that I can learn about this Katy Perry person and also know why she was picked to go to Mars recently. So it goes online and searches about Katy Perry. Or rather, it knows that it needs to go online to search about Katy Perry. But the model is self-contained. It just works with its knowledge base, as with its training. And let's say it doesn't have information about Katy Perry. So it says, yeah, I need to use this web search tool. It then says, based on this query, based on this prompt, I need to use this web search tool. So it will then tell you that, yeah, based on what the user asked, take this web search tool, take this query, which is who is Katy Perry, and run a web search. Run a web search. It can be a web search tool integrated with Google or Bing or whatever. Yeah, run this search. Now, one thing that you have to understand about tool calling, a lot of people feel that it is the model that is going to call the tool. No, the model is not going to call the tool. The model is going to suggest the tool. Yeah, it's going to suggest the tool. You are the one that will call the tool because you are the one that provided the agent with the model, rather, with the tool. The model is not going to call the tool. You are going to call the tool. The model's job is to suggest which of these tools are to be called. That's the first thing. It suggests which of these tools are to be called. Then it also, I think I can switch to a different color now. It also provides the arguments. Where's the eraser? Okay. It also provides the arguments for this tool. Yeah. It also provides the arguments. That's, for example, for this web search tool, the query. It provides the query. It extracts the query that you're going to pass to the tool. If you asked a question like, okay, how many users are in our database? If you had asked a question like, how many users are in our database? It is going to, based on what this source info expects, maybe it expects a database connection or it expects a SQL statement. Let's assume it expects a SQL statement. I think that's more appropriate. So let's take our database. Let's say instead of database, this tool expects a SQL statement. So it expects SQL. So if you ask the query, how many users are in our database? This model is going to generate an SQL statement, suggest the source info tool, and tell you to pass this SQL statement to the source info tool. That's what the model does. It will extract your arguments for you and suggest the tool to use. So it will say, use this tool, and as you have defined this tool to need these arguments, it is going to get the arguments. It's going to help you extract the arguments from the user's prompt. So that is what tool calling is. That's what tool calling is. Note, the model doesn't execute the functions. The model doesn't execute the tools. Your code process is what is going to execute the tools. But the model's job is to suggest the tool and also get you the arguments for the tool. So I just thought it's very, very important for us to get that out of the way so that you can know what tool calling is all about. And now we can actually go into our demo, and we'll be doing that in VS Code. And now in VS Code, we're going to be looking at how to perform tool calling in LangChain. So I've already created a folder where we're going to run all our demos. And what we're going to do is that we're going to look at two different strategies for performing tool calling in LangChain. The first is using function definitions, and the second is going to be by using a Pydantic model. So we're going to be looking at these two strategies, but the main purpose of this demo is to show you how to actually perform tool calling, whichever of these methods you are going with. So to begin, first, let's create a virtual environment. I'm going to be using the command palette of VS Code to create that. So let's create a virtual environment in Python. It's take a few seconds. And yeah, I think it's done. So with that in place, I'll then pull up my command line, which, as you can see, we now have the .venv to show that virtual environment is active. If it's not active, make sure you activate it based on your operating system. So we have our virtual environment, and the next thing I'm going to be doing is installing the dependencies, the required dependencies. And for this project, I'm going to be installing LangChain, obviously. I'm going to install LangChain. And I'm also going to be installing LangChain OpenAI. LangChain OpenAI, that's the LLM provider we're going to be using for this demo. And also, one thing you have to note is that you have to use a model that supports tool calling. Not all models under this provider support tool calling. I think the first Gemini models that came out, 1.0, I don't even think 1.5. I'm not even sure if 1.5 1.5 supports tool calling, but 1.0 they didn't support tool calling. So and even GPT 3.5 doesn't support tool calling. So you want to make sure that you're using the model that supports tool calling. So we're going to be using OpenAI. So I already said that. Let's install our dependencies. Say pip install LangChain and LangChain OpenAI. LangChain OpenAI. Yeah, I think we also need to install the OpenAI package. Yeah. So install LangChain, LangChain OpenAI, and OpenAI. Let's install these three packages. This might take a while, so if it takes too long, I'm just going to pause the video and then we'll come back when it's done. Oh, it's done. It's done already. Oh, cool. Pretty cool. So we have installed those. That's good. If we look at our lib folder, we have LangChain, LangChain core, and we also have OpenAI, and I believe we have LangChain OpenAI. So yeah. So we have our dependencies in place. That's pretty cool. Now I'm going to create a file for the first demo. The first demo where we're going to be using function definitions. Basically to do tool calling. So I'm going to say tool calling with functions. dot py. To calling with functions dot py. So we have our file. Let me close out of this command line for now. So we have our file. And the first thing we're going to do is to bring in our model wrapper for OpenAI. So LangChain OpenAI, import chat OpenAI. And I'm just going to set it up. That will be model, just a model equals chat OpenAI. Then we pass in the model that we want to use. I'm just going to use GPT-4o mini. Yeah, GPT-4o. So we have GPT-4o mini in place. Yeah, so this is good. This is good for what the demo we want to do. GPT-4o mini is good enough for the demo we want to do. It supports tool calling. Yeah, you have to use a model that supports tool calling. Now, the next thing we're going to do, like I said from the old whiteboard stuff, you have to give your model tools. You have to give your model tools. And based on the query, the model will figure out whether it needs a tool. And if it needs a tool, it's going to figure out which of the tools you gave it is going to use. And it's also going to extract the arguments for you. So we're just going to go simple now. I'm going to be creating two functions. One is going to be an addition function, and we're going to create a multiplication function. So we're going to create these two functions. We're going to give it to our model. Then we're going to prompt our model to kind of trigger a tool call operation. And we're going to see what it does for us. So we're going to create two functions, like I said. The first is going to be an addition function. So def add A, which is an int, and B, which is also an int. So this function. Now, your docstring is the most important thing here. Yeah, your docstring is the most important thing here when you're creating your function. Because your docstring is where you're going to describe what your function does. You're going to describe what your function does. You're going to talk about the arguments it collects. And sometimes also you have to describe the return value, what it returns, the data type, and what it represents. So this is like prompt engineering for the tool itself. And that is how your model is going to be able to recognize which tool to call. Yeah, that smart decision your model is going to make to pick the appropriate tool is not going to be based on some name you gave your tool. It's going to be how well you defined your tool in this docstring. So for this docstring, the first thing we're going to say is what our tool basically does, which is that it adds two numbers. That's two numbers, which are integers. So the two numbers are integers, so we don't expect any floats. And we're going to say that it takes args, A, which is an int, arg A, which is an int, even though it can kind of imply it from what we wrote here, but you can still tell it this way. First integer, and B, which is also an int, is the second integer. I can also say, yeah, it returns an int. And here we can come down and say returns or response. Response is an integer. Let's say sum. Response sum of the two integers. Let me just say sum of the two integers. Yeah. So that's our first function. So we write that. We write the docstring. We've described it, but we need to write the function itself, definitely. So here we just say return A plus B, and that's fine. So returns A plus B. In the same vein, let's define our next function, which will be a multiplication function. We just say multiply. It will also take two integers, A and B. Definitely return an integer. And I'm just going to copy this docstring and change a few things. So copy this, bring it here. We'll say multiplies two numbers, multiplies. Yeah, so multiplies two numbers, which are integers. The args, same A, and it will be more, response will be the product of two integers, product of the two integers. So the multiplication by the multiplied value or the multiplied result of the two integers. So we defined multiply. and we define the addition function. So what's the next thing we do? What's the next thing we do? We are going to give these tools to our model. We're going to give this tool to our model, and we're going to create a super model. Yeah, we're going to create a super model, a model that has tools, a model that can make use of tools or suggest tools and also extract the arguments. So I'm going to say model with tools. But first, I'm going to create a list of my tools. So I'm going to say tools, and that will consist of add and multiply, because the model expects a list of tools, at least the function that we're going to use to connect our tools with the model. So model with tools equals model.bind, model.bind tools, and we give it the tools. So we create a list of tools. Then we create a super model. That's a version of our model that has tools, which is basically taking our vanilla model and calling bind tools on it and giving it the list of tools. So we have that, and this model with tools is what we now query with a prompt and invoke. So let's do that. First, I'm going to create a prompt, and I'm going to say, what is $100? $100, yeah. What is $100 in, let's say, 10 places? So what's the $100 in 10 places? And we're going to take this prompt and invoke our model with tools dot invoke, then pass it the prompt. We'll pass the prompt. So model with tools, give it the prompt, then we can print out this response. Print out the response. Pretty cool. And now we can see, we'll be able to see our response. We'll be able to see what we get, what the tool suggestion is. Let me pull up my command line. Now you will need to add your OpenAI API key. We're using OpenAI as a model, so you have to add your OpenAI API key. If you're using Gemini, you know what to do. That's with the chat Google Generative AI wrapper from LangChain, and you add your Gemini API key. But for here, I'm going to say export OpenAI API underscore key equals. Then I'm going to add my key, but I'm going to be adding that off camera. So yeah, I'm going to be adding that off camera. So see you after I add it. So I have added my OpenAI API key. Now we can run this function, or rather, we can run this file. Before we run it, let's just see what we did again. We brought in our model. We created an instance of our model wrapper, and we told it to use GPT-4o mini. And we created two functions, gave it appropriate doc strings so that our model can be able to figure out which of them it's going to need in case the prompt requires it. Then we create a list of tools, which we then pass to our model by calling the bind tools method. We use it to create a super model that has tools. Then we have a prompt that suggests multiplication. So we're expecting it to actually suggest the multiply function. And then we invoke our prompt. We invoke our model with the prompt. So let's see what we get when we run the file. I'm going to say Python tool calling with functions. And let's hit enter. There's definitely going to be a little latency because we're calling the OpenAI service. But when it's done, we get our results back. So we get our results back. It gives us the content. It says if you're looking to divide 100 into 10 equal places. Oh, divide. Interesting. Let me see. Let me look at, let's check the tool section. Token usage, simply divide. I don't think there's a tool section. Because he actually thinks I'm suggesting he thinks I'm suggesting division because I said $100 in 10 places. Let's see. What if we say what is $100 how do we invoke that? What is $100? Let's just say multiply by 10. So this is where you have to make sure that your prompts are very, very well thought out, because it actually makes sense that it sees it as a division. Like, okay, when I say what's the $100 in 10 places, that sounds like a division operation. But let's be explicit. Let's say what is $100? What is $100 multiplied by 10? Yeah, multiplied by 10. Let's be explicit first. Then probably before we end this video, I'm going to come up with something smarter. So what is $100 multiplied by 10? Let's say Python 2 calling with functions. Let's go. And this time, if we scroll up and see our result, first we have the content, and you see it shows that there's a tool call. It says tool calls of the function. The tool is a function, and the arguments are A100, B10. And the name of the suggested function is multiply. The name of the suggested function is multiply. Amazing. Let me see if I can come up with something smarter and still get the multiply. I just want to get that. This sounds too direct. Let's say, how much do I need to give $50 to 30 people? Yeah. How much do I need to give $50 to 30 people? That should definitely suggest the multiplication. So let us we run that. Say Python to call in with functions. And yep, to call. You see the content contains nothing. It doesn't return a normal typical content. It just suggests a tool. Tool calls, it says we need arguments A 50, B 30, and the name of the function to call is multiply. The name of the function to call is multiply. Amazing. Simply amazing. Let's try and see if we can trigger it to suggest the addition function. Let me look for another smart thing to write. I'm just going to comment this out. And I'll say prompt equals let's say if I have 10 apples, let's see if we can solve word problems. And Ben gives me 5. How many apples do I have? Do I now have? So if I have 10 apples and Ben gives me 5, how many apples do I now have? Let us see. This is an addition problem. So let's try and see what tool calling is going to get us. Tool calling. And yep, it gives us our response back. The content is empty once again because it recognizes this as a tool call operation. And it tells us you need 10, A10, and B5 as the arguments. You see here, arguments, you need A10, B5, and the name of the function you need to call is add. The name of the function you need to call is add. And that's how tool calling is. You give the model a bunch of questions, and based on the query, it's going to determine if this is a tool call operation, then it's going to suggest the tool, and it's going to extract the argument. Now, here we've used simple functions, but this is where all the power is, because these functions could easily call an API service. They could call an external service. They could search a database. They could do any kind of custom operation that you can typically do in a software application and return a response. And the model will be able to work with this and be able to introduce it into the workflow of your applications. So yeah, that is tool calling. And now we've been able to see how to do it with vanilla functions. In the next section of this video, which is coming right up after this one, we're going to be looking at how to use Pydantic models. How to use Pydantic models to get something that looks more structured, or if you just prefer using that based on the benefits of using a validation library like Pydantic. So let's do that next. So in this section, we're going to be looking at how to use Pydantic models to write our tools. The previous one, we looked at using vanilla Python functions, but Pydantic has a couple of benefits that can help you, especially in the definition of your tools and in managing data types. So I'm going to create a new file and say tool with Pydantic. Tools with Pydantic. Let's say tools with Pydantic.py. So tools with Pydantic.py. To begin, I'm first going to copy all this model definition stuff so that I don't have to retype it, because we're also going to need it in the Pydantic version. Then we need to import some utilities from Pydantic. So from Pydantic, first we import the base model that our two classes are going to inherit from, and the field that we're going to use to define the properties of our Pydantic classes. So we have Pydantic imported and we have our model set up. To use Pydantic to write your tools, you have to create your tools as Pydantic classes or classes that inherit from the Pydantic base model. Then you use your fields to define what takes place. Yeah, use your fields to define what takes place in the tool. What takes place in the tool, and at the end of the day, you can just you can bind that the same way we bind the functions. You can bind that to your model, and your model will be able to pick which of the Pydantic classes that represent the tool is responsible for carrying out the operation. So we're going to say class, first class add base model. We create our class, and we also have to add that doc string, that important doc string. We have to add it. So we say adds two integers. Adds two integers. These are quite simple now, and to a large extent, you want your definitions to be simple and straightforward so that you don't confuse the model. But just try and make sure that it contains all the necessary details. So adds two integers. Now, instead of let me just bring this back up. I don't think I need to create all that. Instead of having to explain all your arguments and all the other stuff in your doc string, like we did with the functions, for Pydantic, you should simply just create fields. You create fields and you give them descriptions, and you can also use a lot of the Pydantic tools for defining what a particular field represents, like using frozen, giving default values and stuff like that. You can take advantage of all those utilities. Well, but for now, we keep things simple. Our a, which is the first integer, is going to be an int. We set it equal to a Pydantic field. We don't have any default value for it, so we are trying to tell our model that this has to be provided. This field has to be provided. So I'm just going to use ... because we don't have a default value. Then we add a description. Simply first integer. Just like we did the previous one. First integer. And b is going to be similar because our fields are quite simple. So we also have the field for b, and we provide a description, which is second integer. So because we said it adds two integers, we're just telling it this is the first one and this is the second one. So yeah, those are the fields that it's going to extract for us from the prompt, and will be used as arguments, will be suggested to be used as arguments for our function call. Now, in the same vein, we're going to create another class. I'm just going to copy this class because we're just going to do something similar. And this will be the multiply class. The multiply Pydantic class. This one will say multiplies two integers, and a and b will remain the same because their definitions are the same. Now, these are defining the fields. It's up to you to also define the implementation of the multiplication and implementation of the addition. But because that is not really necessary to what the model is trying to do with two calls, you are the one that will do that yourself. Like I said, the model is not going to call the tool yourself for you. It's not going to call the tool for you. You are the one that will call the tool. So you should make sure that you also add the implementation for this multiplication and this addition as methods in these classes. So we get these two in place, and just as we did with the previous examples with functions, we create a tools list, give it add and multiply. Then we say model with, this time I'm going to say Pydantic tools. It's still tools. Pydantic tools are not different from function tools. It's just how they are created that is different. So say model dot bind tools, and we'll give it our tools list. Next, we create our prompt, and I'm just going to pick my addition example from here. Pick our additional example from here and give it to the prompt. Then I can say response equals model. Let me just copy that. It's quite long. Model with Pydantic tools dot invoke. Then pass it the prompt. Pass it the prompt. Now, we've seen this before. It will suggest the tool, and yeah, it will suggest the tool as expected. But instead of having to deal with all those that response object that I was trying to like do needle in the haystack kind of search to find what the function call is and what the arguments are, you can simply just print out response.toolCalls. Yeah, you can just print out response.toolCalls, and it will just give you the tool call suggestions that the model has extracted for you. So let's do that. Let me bring up the command line. Make sure that you've added your OpenAI API key. And now let us run Python tools with Pydantic. Python tools with Pydantic. Now for this, we expect it to suggest addition and suggest the two arguments which we've defined as fields. So let's run this. Take a few seconds. As you can see, we just got the tool call section. Yeah, we just got the tool call property of the response. Just that. And it tells us that the tool we need is add. The arguments we need, A is 10, B is 5. And it gives us an auto-generated ID for the tool. Yeah. And it says that this response type is of the type tool call. This response type is of the type tool call. And as you can see here, it returns this tool call as a list. It returns it as a list because there might be sometimes you might make a call and it requires calling multiple tools. So it's that versatile. The tool calling feature is that versatile that it can suggest more than one tool based on what was written in the prompt. For example, let's say there's a traveler and the traveler says that he's trying to go from one distance to another and also know the weather conditions at the destination. You can have a find distance tool and a find search weather tool, a find distance tool and a search weather tool. And the tool calling feature will be able to extract these two tools as the tools to be called and also bring out the necessary arguments for them. So yeah, that is tool calling in LangChain. And I hope that from now on, you can confidently say, yeah, I do understand tool calling in LangChain.